right, let's get started with the second lesson in the in the circle unit. Last time we talked about what central angles are. This time we're going to talk about inscribed angles. All right, so inscribed angles in circles. An inscribed angle is an angle whose vertex is on the circle. Okay, so let's take a look at an example. Try to draw a circle here. Oop. Hold on a second. Let's try that again. Try to draw a circle. Okay. An inscribed angle has the vertex on the actual circle, and there's so many different possible ways to look at it. Okay, if we talk about a point right here, and I draw an angle, that is an inscribed angle. Okay, the point of the angle or the vertex is on the actual circle. It's not inside of it. It's not on the center. Okay, just recap a difference from last time. A central angle is when the angle, the vertex, is on the center. So if this were circle C, the vertex of it is on point C. That's your central. And inscribed is when it's on the side. Okay, so the vertex is on the side. So remembering the difference between the two. All right, what I want you to do, you're actually going to start this on your own real quick. Go through, pause the video, and I'm going to pause too, and I want you to just identify whether the picture gives you a central angle or an inscribed angle. So you're going to go through each example one at a time, and write, you can either write central or inscribed, or you can write C or I. All right, so we have 6 examples to look at. Decide if they're central or inscribed. Go ahead. All right, and let's take a look. The very first one is a central angle because it's angle AOB, or angle O. The vertex is on the center of the circle. All right, the next one we see, angle ABC, is inscribed. The vertex is on the circle, not in the middle. All right, the next one is a central circle. Okay, even though we don't have letters, this is the center of our circle. All right, this is a central angle, sorry. This one is inscribed, and the last one is inscribed. So really just understanding the difference between what it means to be a central angle and an inscribed angle. All right, central angle, the vertex is on the center of the circle, and an inscribed angle, it is on the outside of it. All right, so what does this mean? How is this going to help us? All right, so it says now we know what central angles and inscribed angles look like. Let's find out their properties. Let's start by recapping what we know is true about a central angle, which is this one over here. Okay, the directions say move the formulas to decide which one matches with a given angle in the circle. Well, think back to last time. What did we learn about the central angle of a circle? It is equal to the arc length of the outside. Okay, so for example, angle CBA, or however you want to name it, is going to be the same measure as arc CA. Okay, so the measure of arc CA is equal to the measure of angle CBA. We've already decided that. Okay, so looking at the formulas that they give us, we know that the angle, if I could break that in half, just kidding. All right, well, we know that the angle equals the arc. Okay, so this part is going for this right here. Angle equals arc is for my central angle. So that means that we're given the formula for an inscribed angle. So this is what's new to us. In an inscribed angle, the measure of the angle is the arc divided by 2. So this angle right here is 1/2 the measure of the arc. Okay, so in this specific example, angle E is equal to 1/2 the measure of arc FD. Okay, so if I tell you that arc FD is 100, think to yourself for a second, what's going to be the measure of angle E? It's going to be 1/2 of that. It's 50. Right, and likewise, if I tell you the measure of angle E is 40, you could use that to help you find the measure of arc FT. Okay, we're going to double that. If measure of angle E is 40, the arc is 80. Okay, so you've got to distinguish between the two. If it's a central angle, the arc equals the measure of the angle. If it's an inscribed angle, the arc is double the size of the angle. Hold on. All right, on to the next page. Okay, so we're going to fill in the blank using our words. Isn't this super pretty? It says for central angles, the measure of the angle is blank the measure of the intercepted arc. Okay, I want you to pause this video and I want you to fill in these two on your own. Okay, so you can kind of just draw an arrow and move it up. Pause it, try it on your own, then we'll come back and do it together. It's kind of just recapping what I just said. All right, let's see if you got the same things as I did. For central angles, the measure of the angle is equal to the measure of the intercepted arc. And then for inscribed angles, the measure of the angle is half the size of the measure of the intercepted arc. All right, so just kind of recapping those 2 points. All right, so let's kind of finish this up. Let's complete this flowchart together to help us with our steps, and then we're going to actually do some problems using that information. Okay, so as you can see, we have a whole bunch of boxes, and we have some words that we're going to fill in. Okay, just kind of give you another way to think of it. So the top thing is what's going to be which type of angle that we're looking at. Are we looking at an inscribed, or are we looking at a central angle? So you can just fill in the words as we go, just handwrite them in. I think that would be a lot easier than circling and drawing arrows everywhere. You're going to confuse yourself. Okay, so which type of angle are we looking at? Are we looking at an inscribed or a central angle? So we can drag those words up. Me dragging should give you plenty of time to go ahead and write. So let's start on the left side of our flowchart. Let's start with our central angle. Are we looking for the blank or the blank? Meaning, are you trying to find the angle measure, or are you trying to find the arc? Okay, the angle measure or the arc. Why does it matter? Okay, so if I'm looking at, we're seeing central. Sorry, you know it's a central angle. And you said, okay, find the angle measure. What do we do? Well, what do we know? We know that the arc is equal to the angle. No matter what. If I tell you the arc is 40, the angle is 40. Okay, if I tell you one is 30, the other is 30. All right, so that can go into both of those boxes. Okay, so whenever it's a central angle, if you're looking for the angle or you're looking for the arc, the same rule applies. You don't have to think back and forth. They're just equal to each other. Okay, now if I'm going, looking at an inscribed angle, it matters which direction I'm starting with. Am I starting with an angle or am I starting with an arc? Because we got to think about it. One is half the size of the other. That means the other one is twice as big. So you got to think, am I going to multiply or divide? Which way am I going to go? So let's start from the angle. If you're looking for the angle measure, if you remember, the angle measure is smaller, okay? The angle measure is half of the size of the arc. So 1/2 is the same thing as dividing by 2. So if you're looking for the angle measure, you're going to divide the arc by 2. Likewise, if I give you the angle and you're looking for the arc is 2 times as big as the angle. So we multiply. So you just got to remember which direction you're going. You've got to remember that the arc is going to be bigger than the angle for an inscribed angle. For a central angle, they are both equal. Okay, then you can always flip back to this flowchart if need be. I'm going to pause the video and you're going to take some time and you're going to solve these problems on your own. You are finding X. Okay, so the first thing you should do is decide, hey, okay, so use that flowchart, central angle or inscribed. What am I finding, the arc or the angle? Okay, so see if you can do this on your own. Pause the video. I'm going to pause too. When you're done, turn it back on. I'll talk through each problem and you can check your work, okay? Pause. All right, take a second, look over the answers. Check your work. In about 20 seconds, I'm actually going to go over the problem so you can see and understand why you got something wrong or right or whatever. Okay, if you got everything right, you can go ahead and fast forward on to the next screen. If not, then you can go ahead and listen to the explanations. All right, let's start with this first one. So once again, deciding central or inscribed. This is a central angle because I see that if I'm looking for X, which is right here, first of all, I'm looking for an arc, okay, and that is going to give me information from a central angle. So that angle is 123 degrees, therefore the arc is 123 as well. Okay, so I decide I'm looking for an arc, and I decide it's the central angles, and the arc equals the angle. All right, on to the next one. It's inscribed because look where X is. The angle is down here. It's not the center. And I am looking for an angle measure. So going back to my flow chart, I know that if it's an inscribed and I'm looking for an angle, that I divide the arc by 2. So I'm going to divide this by 2, and I got 40. The third one, okay, I see it's a central angle because my X is in the middle. I am given a couple arc lengths, so we don't always need all the information we're given. If I'm finding this angle right here, I'm going to outline it, and I see that I'm provided its arc. And remember, in a central angle, the arc equals the angle. So therefore, the angle is 120 degrees. All right, in the next one, I have 91. How do we get that? Okay. Well, this is an inscribed angle because the vertex is on the outside. So we're trying to find x, but here's the arc of x. So if you notice, there is no angle made by it. Okay, there's no two sides that make an angle with that arc. So I'm going to have to think. We're given something for a reason. Here's the angle I'm given. I'm going to outline it in green. And this is 95 degrees. How is that going to help me? Well, it's an inscribed angle, so I can find the measure of this arc right here. Okay, why? I can multiply it by 2 because the arc length is twice the size of the angle. So 95 times 2 is 190. Now think back to the last lesson. How many degrees is the entire circumference of the circle? It's 360. So what I can do is I can add my 79 and 190. I would get 269. And then I can go ahead and I can subtract that from 360. Okay? And that's how I got my 91. Okay, so using the information provided. All right, the next one. Find the measure of arc CFD. So definitely go ahead and trace it. Be careful. This is a major arc because it's A, more than 180 degrees, and I'm using three different letters. So I know that's going to be a pretty big number. Okay, so I knew that my answer of 302 degrees made sense. So what I can do is a couple different ways. Here's the easiest way. If it's a major arc, I'm going to subtract this guy. Let me outline it in blue. This piece from 360 because that's the only part that's not part of my major arc. So first, that's a central angle, so I need to find the measure of this angle. And that's actually not too bad, guys, because take a look right here. I have vertical angles. Bam and bam. Yes, this one's broken into two pieces, but that whole thing equals 139. So if this whole piece of the pie is 139, I can subtract the 81 from it to give me that smaller piece. And I get 58. So this arc right here is 58 because this angle is 58. So to get this guy, I did 360 minus 58. Ow, I just ran into something. Okay, so you've got to start looking at what you're given and decide how is that going to help me. Okay, first start inscribed or central. What am I looking for? What do I have? All right, the next one, I'm finding this arc right here. Okay, well, here we go. It's an inscribed angle. So the arc is going to be 2 times the measure of this angle right here. How are we going to find that angle? Well, if you notice, I have a triangle. So I already have 2 measures, 49 plus 70. Okay, that's 119. So what I can do is do 180 minus the 119. And I get 61. Okay, 49 plus 61 plus 70 is 180. So the measure of that angle is 61. So to find the measure of the arc, I will double that and give us 122. All right, 2 more. Next one, we are looking for the measure of angle MIJ. So definitely decide first where you're looking. So it's this guy right here, MIJ. Okay, how are we going to do this? Well, it's all central angles, so that's actually going to help us out a bunch. If this is 95, that means this is 95, which means this is 95 because of a vertical angle, which means that this is 95. Okay, now I have 2 sets of vertical angles in here. Those 2 and then these 2 I'm going to color in green. These 2 angles are going to be equal to each other because they're vertical. All right, so one way I can think about it is, well, these 2 right here are supplementary. They add up to 180 because of the straight line going through the center. So if I do 180 minus 95, I get 85 for this. And since it's a central angle, my arc is 85 as well. Okay, on to the next one. Last one. All right, so we got to use our brains here. Now, I'm only given one thing. This angle is 42. That means that this arc is 84. Okay, now here's where you got to think. Here's angle Y. What do you notice about angle Y? It's hitting at the ends of, it's hitting the circle at the ends of that diameter, diameter being a line that goes from one end to the other, passing through the center. So if it's hitting at the diameter, what is the measure of this arc? It's half a circle. It's a semicircle, which is 180. Well, if that arc is 180, that's telling me y is 90 because it's an inscribed angle, so it's half of it. So I got y to be 90. Oops, sorry, x should not be 42. I'm sorry, not 40. Okay, then how do I get x? I do 90 plus 42, and I subtract it from 180, so we get 48. Sorry about that. Okay, all right, replay anything you need explained again. The rest of us, let's flip on to the last 2 pages. All right, inscribed quadrilaterals. Inscribed, guys, means that the vertices are on the outsides, okay? So quadrilateral is a 4-sided figure. So an inscribed quad is a quad that is inside of a circle where the vertices are on the circle, okay? What do we care? Because of this. Opposite angles are supplementary. Doesn't matter what shape it is. It doesn't have to be a parallelogram or whatever. If it's a quadrilateral inscribed in a circle, opposite angles are supplementary. So what does that mean? The measure of angle B and D is equal to 180. Oops. I want to color coordinate that. B and D is 180. And then A and C is 180. All right, so we can use that to help us find angle measures. Okay, so our directions say, find the measures of the angles in the quad. We're given 1, that's all we need, okay? So first of all, D is 90. It is supplementary with B. D plus B equals 180. Okay, well, it's 180 minus 90. It is 90. All right, and then these 2 are supplementary. So this one's 100. Okay, and we could go through and find all of our arc lengths if we wanted to. No big deal. Okay, but that's our information. And we're done. Bye-bye.